All right, folks, we are back with the 3-4 worksheet, all about glide reflections and combining some of our already created rigid motions. So starting with number 9 here, Damien draws the diagram for the glide reflection of a translation 07 composed with a reflection across the y-axis of quadrilateral ABCD. What error did he make? So remember, according to this set of instructions, he took quadrilateral ABCD, he reflected it across the y-axis, which would put it up here, and then translated it over here. But that's not what happened. He took this shape, translated it first, and then he didn't even reflect it across the y-axis. He just translated it again. So he actually made two errors. He translated first instead of reflecting. Translated first instead of reflecting. And then he translated again. And he didn't do a reflection at all. And didn't do a reflection at all. Number 11 is a tricky one. All right, so if you didn't get this, that's okay. What are the coordinates of the vertices of triangle A prime, B prime, C prime after reflection across a line through point P with a y-intercept at y equals -2? So in this case, we're actually going to be reflecting this triangle across a diagonal line. So if we put a y-intercept down here at y equals -2, and we connect the 2 points, point P and that y-intercept, and we show what that line would look like, that is going to be our reflection line. So the first thing we're going to do is reflect across that line. So when I look at this, I'm just trying to make sure that my new shape is going to be the same distance away. So I see like point B is like 1.5 diagonal boxes from the reflection line. So point B prime is going to be 1.5 diagonal boxes on the other side of the reflection line. So that's B prime. Same thing with C. It's 1.5 diagonal boxes from the reflection line. It's going to be 1.5 diagonal boxes from the reflection line. And then A is, let's see, 1, 2, 3.5 diagonal boxes from the reflection line. So we go 1, 2, 3.5. Here is A prime. And then we can go ahead and connect. We're not done yet, right? Because this was a 2-step. But this is the beginning of it. And then we say followed by a translation of 3, 3. So over 3, up 3 for every point here. So we can just take B prime, go over 3, up 3. There's B double prime. And then C prime, go over 3, up 3. There's C double prime. And A prime, over 3, up 3. There's A double prime. And we can show the actual final placement of our shape. All right, so that's where we will end up, is right here. All right. Number 12, what are two rigid motions with a composition that maps triangle JKL onto J prime, K prime, L prime? We could do this in a bunch of different ways. I'm going to try and do this like a glide reflection. So I'm saying if I want this shape to map onto this shape, the first thing I need to do is decide whether moving it to the left or moving it up will line it up for a reflection. If I move it to the left, I'll be able to reflect it over a line around here, and that will make the shapes the same. If I move it up, I can't reflect across a vertical line because it won't create the same shape. Moving this up means it'll still be rotated with respect to J prime, K prime, L prime. So I am going to translate it to the left. So I'm going to say, all right, it's going to start with a translation. So I'm going to put that to the left here, or to the right here. Translation, how far am I moving it over? I want to move it over so K lines up with K. So that's 1, 2, 3, 4, 5, 6. So translation of -6 to the left and 0 up or down. And then once I move it over, I need to reflect it. So once I have it moved over, I'm going to reflect it across a line. So if K prime is right here, the line exactly in the middle of my old point and my new point happens to be the line right here, the line at y equals 1. So it's a reflection across the line y equals 1, composed with a translation of -6, 0. There are other answers possible here. Let me say that. Other answers possible. There are lots of different ways that we could do this. That's just one possible way. Up here, we've got a whole bunch of information. We've got coordinates A, B, and C, and we want to determine the coordinates for each glide reflection. Suppose P is the line with the equation x equals -3, Q is the line with the equation y equals 9, and R is the line with the equation y equals -2. So for 13, we are taking the triangle ABC, we are reflecting it across the y-axis, and then translating it 0, -2. So I'm going to take my points that were listed up at the top, and I'm going to write in sort of the intermediate, right? So if A is 6, -4, and I'm reflecting over the y-axis, my new point will be -6, -4, right? Reflecting across the y-axis will change the x-coordinate to be negative. My B coordinate is 3, 8, so the new one is -3, 8. And my C coordinate is +7, 9, because it was -7, 9. And then the next thing I need to do to these coordinates that I've created is translate 0, -2. So just subtract 2 from the y coordinate. And I get A prime is -6, -6. B prime is -3, 6. And C prime is 7, 7. All right, next one, number 14, we are taking this triangle, reflecting it across the x-axis this time. That means I'm going to make my y-coordinate the opposite of what it is, and then translating it up, or left 4 and up nothing. So I'm going to take my points originally given to me. A was 6, -4, so now A is 6, 4, right? I'm changing my y-coordinate to be the opposite. B would be 3, -8, and C would be 7, or -7 rather, -9. And then I want to do my translation 4 units to the right. So A prime is going to be 6 plus 4 times, or not times, 6 plus 4 is 10, comma 4. B prime, we're adding 4 to the x-coordinate, will be 7, comma -8. C prime will be -3, comma -9. And that'll be your answer. Number 15, we are reflecting across the P line that was given to us up here. Let's go find that one. Suppose P is the line with the equation x equals -3. So that's where we're going here. So reflecting it across x equals -3, we'll take our original point is 6, -4. To reflect across x equals -3, I need to figure out how far away from 6 -3 is. That's 9 units below 6. So I'm going to go 9 further units below -3 to make that reflection. So -3 minus 9 is -12. So my first point, my first intermediate point is -12, 4, or -4 rather, I'm sorry. The next point, B is at 3, 8, and I'm reflecting it across x equals -3. 3 is 6 units above -3, so we need to go 6 units below -3, so that'd be -9. So my next coordinate is going to be at -9, 8. And then my third point is, let's see, C is -7. -7 is 4 units below -3. So I need to go 4 units above -3, and that's +1. So that last coordinate is going to be +1, 9. Then I need to do a translation up 8 units. Change my y coordinate by 8 units. So that would make A prime, -12, -4 plus 8 is 4. B prime is going to be -9. 8 plus 8 is 16. C prime is going to be 1. 9 plus 8 is 17. And that'll be your answer. Numbers 18 through 21. Write a rule for each glide reflection that maps triangle DEF to triangle D prime, E prime, F prime. So there are a lot of ways that we can do this. I think the easiest way might actually be to draw these two shapes on graph paper and then find, like we did on number 12, what move would make them line up with each other. And then we could do a reflection that is going to cause them to flip on top of one another. So in this case, it gives us a lot of opportunities. We have a lot of different options. I'll just give you some of the ones that I found, or one of the ones that I found here. You can find your own if you're looking on graph paper to try and figure out which way we would move. So one way that I could do number 18 is by doing a reflection across the line x equals 1 combined with a translation of 0, 3. So over 0 up 3. That's just an example. For example. Of course, there are tons of ways that you can make this happen. Number 20, same thing. We could maybe do a lot of different things. The way that I decided to do this one was to do a reflection across the line y equals 2, or y equals -2 rather, combined with a translation of -6, 0, and that worked for me. Number 23. Each parking space in the figure can be the image of another parking space as a glide reflection. What is the rule that maps the parking space where the red car is parked to the parking space where the blue car is parked? So if we're looking at the red car, to find what maps it to the blue car, looks like we are going to reflect it first. If we look over, I'm going to have to move it like I could move it over first. I could do either way. I could move it over first and then reflect it, or I could reflect it and then move it over. Both will give me the same answer in this case. So maybe I'll reflect it first. And of course, I'm looking to see what this reflection line is. This reflection line is y equals 7. So I will reflect it across the line y equals 7. And that puts it up here. So my furthest point out would be right here at number 1. I need to move it over to number 6. So I need to move it over 5 units. So my translation for this entire rectangle here would be over 5 units. So that would make a translation of 5, 0. Right? And there are other ways that you could make that happen as well. Like I said, you could do the translation first and then the reflection. That'd be totally fine as well. Number 24, starting from tile number 1. Quadrilateral tiles are embedded into a wall following a pattern of glide reflections. If the pattern continues, what are the shapes and locations of the next 2 tiles the builder replaced in the wall? So from 1 to 2, there's been a reflection across this line. From 2 to 3, there's been a translation downward. 3 to 4, there's been a reflection across this line. 4 to 5, there's been a translation upward. So then my next thing that would need to happen would be a reflection across an imaginary line right here. Let's see if I can make a shape that even remotely resembles what I need it to. I probably can't, but we can try. Let's see. 1, 2, 3, 4. Okay, so that would be number 6. We would move it over. And then number 7 would just be taking the shape and moving it downward. We would be doing another translation. Something like that. That'd be shape number 7. So if we're continuing this pattern, we would go 1, 2, 3, 4, 5, 6, 7, just like that. Okay? And we can explain by writing down the pattern. We would reflect across the vertical line and then translate down. Oops, start with reflection. Reflect across the vertical line, then translate down. All right. Number 25, match each rigid motion with its image. Let's take a look first at number 1. We're taking triangle ABC, so that's important. That's the one up here. We're reflecting it 180 degrees across or around the point 0, 1. So the point 0, 1 is this point right here. So we're going to take AB, we're reflecting it 180 degrees around this point. That is going to give us JKL. So number 1 is going to be C, LJK. Number 2, a translation, well first a reflection rather, across the y-axis, then a translation up 8 of triangle TUV. So let's find TUV. We are going to reflect it across the y-axis, and that's going to make it, over here. So TUV is going to go to QPR, and then going up 8 from that is going to give us DFE. So that one is B. Number 3, we've got a DFE starting out. We're going to reflect it across the y-axis. That's going to move it way over here. And then a translation over 2 is going to put it back on ABC. So that's going to be A. And then, of course, process of elimination makes number 4 D. Number 26, suppose the line with the equation y, or suppose M is the line with the equation y equals 3. Given A, B, and C, what are the coordinates of the vertices of A prime, B prime, C prime if we reflect over that line and then translate -4? Let's do it. So we're starting with A is at 7, 1. We're reflecting over the line y equals 3. So we're looking at the y coordinate. The y coordinate is a 1. 1 is 2 units below 3. So our new number is going to be 2 units above 3, reflected over that line. So that A is going to be, I guess it's technically A prime. I always talk about primes and double primes, and then they do them differently in the book. Is going to be 7, comma, the number that's 2 units above 3, which is 5. Then B prime, after the reflection, is going to be a 2. And then the number y coordinate, 9, is 6 units above 3. So we're going to make it 6 units below 3. 6 units below 3 would be a -3. And then C prime is going to be, well, it was -5, so it's 3, comma. -5 happens to be 8 units below 3. We're going to go 8 units above 3. 8 units above 3 is 11. And then we're going to take all 3 of those coordinates, and we are going to translate the x coordinate to the left, -4. So that would be 7 minus 4 is 3, 5, B prime, 2 minus 4 is -2, -3, and C prime, or C double prime, depending on how you're counting here, 3 minus 4 is -1, 11. When we compare those to our answer choices, that is answer choice D. All right, hopefully this helped you out. Let me know if you have any questions at all, and of course, have a wonderful day.